Okay, so once again, very good morning all. I hope my voice is properly audible to all. Okay, so in the last lecture, we have started the problems based on the type number 3, that is the member or a rod if it is subjected to the impact loading condition. And based on that, we have solved one problem based in the previous lecture, when the member or the body is subjected to the impact load, then how the stress value will be calculated and how to calculate the strain energy stored in that particular rod. And uh, one more problem is also given for exercise. Many students have solved that particular problem, uh, and accordingly, I have given the replies to them. Those who have solved properly as the correct answers. Okay, so those who have not solved, still there is a time. You can solve it and you can send me the answers by today evening. Okay, so now in the today's lecture, we will solve again one or two problems based on the type number 3, that is the impact loading condition. And this is the problem in front of you. So what is the previous problem we have solved? In that, how to identify the problem by means which formula we have to use. Either we have to go for the suddenly applied load or the gradually applied load, or we have to go for the impact loading condition. And as already I have told you, if we have to solve the problem by using the gradually applied condition or the suddenly applied conditions, that word is mentioned in the statement. For example, the 80 kilonewton force applied on the bar and it is applied gradually. So if it is applied gradually, then we have to use their respective formula, sigma is equal to P upon E. If the load is applied suddenly, then we have to use their respective formula, sigma is equal to 2P upon E. But how to identify the problems, whether it is given on the impact or not? So in that particular statement, they are mentioning the height, the falling height, because in the impact loading condition, the falling height is very important. That means initially there is no any contact between the loading frame and on which we have to apply the load. Okay, there is no any contact between the loading frame and the component. There is a common things in the suddenly applied load and the impact load. Suddenly applied load मध्ये आणि impact load मध्ये common thing आहे. In suddenly applied load also we are applying the load immediately. For example, if I have to apply the 80 kilonewton force from zero, immediately I will apply the 80 kilonewton force. But in suddenly applied load, there is a contact between the component and the loading frame. Means the height is not considered in the suddenly applied load. But in impact loading condition, again we are applying the load immediately. For example, this is the 500 Newton load. We are falling from certain height. Means this 500 Newton load is immediately strike on the component. While applying this 500, I am not applying 100 kilonewton, 200, 300, 400, and then 500. Immediately, the load from certain height, it will get strike on the another component. So that is also one of the type of suddenly applied load. But in the impact loading condition, there is a certain height between that movable load and another component. So this is the common difference between the suddenly applied load and the impact load. So please keep in mind, suddenly applied load मध्ये काय आहे, फक्त तुमची falling height नसणार आहे, आणि impact loading condition मध्ये there is a certain height which is called as a falling height. कारण suddenly applied मध्ये पण आपण 500 न्यूटन हा immediately apply करतोय, आणि impact मध्ये पण हा 500 न्यूटन हा आपण immediately apply करतोय. But what is the common difference? What is the common difference? In the suddenly applied load, there is no any height between the component and the loading frame. But here in the impact loading, there is a certain height between loading frame and that particular component. Okay, so if the height is mentioned in the statement, then we can say that that particular problem is based on the impact loading condition, and we have to use their sigma formula, and then we have to put that particular sigma in the strain energy equation, because the strain energy formula will be same for all the three conditions, that is gradually, suddenly, and the impact loading condition. Okay, so this is the basic difference between the suddenly and the impact loading, and how to identify the impact loading. That example I have given in comparison with the suddenly applied load, because sometimes MCQ questions will be asked based on this particular concept also. What is the suddenly applied load and what is the condition for the impact load? So for suddenly, height is equal to 0, and for the impact, height is given in the statement. Okay, so now, yes, something mic is on, Ajay. Okay. Okay, so now this is the second statement based on the impact loading condition. I will read the statement carefully and then we will solve. A vertical bar of uniform cross-sectional area 400 mm square. A one vertical bar is there and their cross-sectional area is given as a something. Mic is on Ajay Kore. Mute yourself. So vertical bar of cross-sectional area 400 mm square and 1.5 meter long is fixed at the top. So one vertical bar is there, their cross-sectional area is already given. That means instead of giving the diameter, direct value, cross-sectional area value they have given as the 400 mm square. The length is given 1.5 meter and it is fixed at the top. Okay, top end, and is provided with circular disc at the bottom side. At the top side, this rod is fixed and at the bottom side, one circular disc is there, means we can consider it as a collar. Means we can consider it as a collar, full stop. If weight of 500 Newton falls on the disc from height 100 mm. How much weight is falling from the certain height? This 500 Newton load is falling from certain height and that height is also given as a 100 mm. Okay, determine maximum stress set in the bar. We have to calculate the maximum stress induced in that particular bar, or we can consider as a disc, because disc and the bar both are rigidly connected to each other. Okay, so we have to calculate the maximum stress, full stop. Take E is equal to 200 kilonewton per mm square. Young's modulus value is given, full stop. Also determine strain energy absorbed or strain energy stored in the rod and maximum instantaneous elongation of the bar. We have to calculate the stress value also, we have to calculate the strain energy also, and we have to calculate the whatever the elongation is taking place due to this 500 Newton load, that elongation also we have to calculate. If you see this particular statement, in this particular statement, they have not used any word, that is this 500 Newton load is applied impact condition. In the previous problem, if you see here, in the previous problem, calculate the maximum stress induced in the bar due to the impact. Such word is mentioned in the previous problem, but if you see this particular statement, in this particular statement, such an impact word they have not mentioned in the statement. Then how to identify the problem, whether it is gradually applied, suddenly applied, or impact load? So for that purpose, if you read the statement carefully, and here they have written the 500 Newton load is fall from certain height, and that height is given as a 100 mm. This 500 Newton load is also false on the another component in the suddenly condition. It is also applied on the another component in the suddenly condition, but before it is striking on the another component, they have to follow this particular height of 100 mm. That means if the height is mentioned, then that problem we have to solve by using the impact loading condition. Okay, so these are the given parameters. So you just write down all the given parameters. So cross sectional area of the bar is given 100 mm square. Okay, then length is given 1.5 meter is equal to 1500 mm. Then the load is given, P is equal to 500 Newton, which will be considered as the impact load. Then height, falling height is given 100 mm. Then Young's modulus is given in 200 kilonewton per mm square. Kilonewton per mm square. So we want this particular E value in the form of Newton per mm square. So already mm square is given. Only we have to convert kilonewton value into Newton. So what I will do? 200 into 10 raised to 3 Newton per mm square. Okay. Then we have to calculate the stress. due to the impact loading condition, we have to calculate the strain energy stored or absorbed in the rod, and we have to calculate the delta L also. Okay, so these are the parameters we have to calculate. Now to calculate this, the figure is in front of you. So if you see this particular figure and statement, so this is the vertical rod. Okay, so this is the vertical rod having the cross sectional area 400 mm square. Their length is also given 1.5 meter. Okay, and this is the movable load. This is the movable load of 500 Newton. The rod is fixed at the top side as per the condition mentioned in the statement. The rod is fixed at the top side, and at the bottom side the circular disc is attached. So this is the circular disc, and there is a certain height between this 500 Newton load and circular disc. This is the height is equal to 100 mm. Means whatever this 500 Newton movable load is there, it is not in contact with the circular disc. There is a certain distance between this particular circular disc and the movable load. ह्या movable load मध्ये आणि ह्या circular disc मध्ये एक प्रकारची height आहे, त्याच height ला आपण काय म्हणतोय, falling height म्हणतो. Okay, now what happened here? This 500 Newton load is comes at downward side, and immediately it is strike on this particular circular disc. And due to this, what happened? Some amount of stress is induced in this particular rod. Some amount of energy is also stored in this particular rod, and the elongation of rod is also taking place. These three values we have to calculate from this particular statement. And as this particular rod and the circular disc are connected to each other, बघा ह्या ठिकाणी connecting point आहे. हा rod आणि circular disc ह्या point ला काय केलेले connect केले. That means whatever value we are calculating for the bar, same value we are considering for the circular disc. Means the strain energy stored in the bar is equal to strain energy stored in the circular disc. Whatever the stress is induced in the bar, same stress value will be there for the circular disc because they are connected to each other. Okay, so this is the statement, and according to this particular statement, this is the figure in front of you. Bar which is fixed at the top side, at the bottom side circular disc is attached, area of the rod is given, length of the rod is given, falling height is given, 500 Newton load, movable load is given, and we have to calculate the stress value. So what I will do now, as per the impact loading condition, as per impact loading condition, what is our formula for the stress calculation? Sigma is equal to P upon A in square bracket 1 plus square root of 1 plus 2H upon delta L. Okay, so this is the formula for the impact loading condition. So I will write the same formula. Sigma is equal to P upon A in bracket 1 plus square root of 1 plus 2H into AE divided by PL. So what I have done here, this delta L value I have replaced in the form of formula, that is delta L is equal to PL upon AE, but this delta L is present at the denominator side. That means 1 upon delta L. Means this PL value will comes to the denominator side and the AE value will comes to the numerator side. Okay, so now this is the formula in front of you. Now simply we have to put the values only. So sigma is equal to P value is given 100 divided by area is given 400 in square bracket this 1 plus as it is, then square root of 1 plus 2H means 2 into 100 into area 400 into E 200 into 10 raised to 3 divided by, again the P value is given 500 Newton into length is converted in meter to mm 1500. Then sigma is equal to, what is the value P upon E?
सर तुम्ही
Yes.
P
1.25.
घेतलीये.
Yes.
P upon A value is 500.
Yes, yes. Here 500. Yes. Yes, 500 divided by 400. What is the value of P upon A? Do this calculation separately.
1.25.
1.25. Okay, then square bracket as it is, this 1 plus as it is, again square root. Square root मध्ये हे 1 as it is. Now do the separate calculation for this term. कुठल्या कुठल्या टर्म आहेत बघा? 2h into AE divided by PL.
21 raised to 3.
How much?
21.33 into 10 raised to 3.
Into 10 raised to 3. Okay, those who have calculated, please send your answer in the chat box. I will check. Send your answers in the chat box. So which value we have calculated? See, 2h into AE divided by PL. In that we have kept two value as it is. H value as 100 mm, A value is given, E value is given, and divided by PL value. So do the separate calculation of this term. 2h into AE divided by PL. Do the separate calculation of this term and write in the square root as it is. Go for more and more simplification. Go for more and more simplification. Everyone, please send your answer in the chat box. Don't do the direct calculations. Sometimes it will create the mistakes in your calculation. So calculate the terms separately. 21.33 into 10 raised to 3. This is the value of 2h into AE divided by PL. This is the value of 2h into AE divided by PL. म्हणजे square root मध्ये जी काही term आहे 2h into AE divided by PL. Calculate that term separately. 21.33 into 10 raised to 3. Everyone has to calculate. Still only few students they are sending the answers in the chat box. Others, please do your calculation and send your answer in the chat box. 2h into AE divided by PL. The answer of this particular term is 21.33 into 10 raised to 3. Okay. Yes, 21.33. Everyone is sending the answer and answer is same for all of you. 21.33 into 10 raised to 3. So now the next step, sigma is equal to 1.25 as it is, square root of 1 plus. Now in the square root, 1 plus 21.33 into 10 raised to 3. This term is there. Now take the square root of this particular term. 1 plus 21.33 into 10 raised to 3. What is the square root value of total term?
146.061.
146.061. Okay. Please check your answer. Don't forget to add plus 1. 21.33 into 10 raised to 3. ह्याच्यामध्ये plus 1 add करा and then take the square root. Don't take the square of only 21.33 into 10 raised to 3. तुम्ही जर तेवढ्याच टर्मची जर स्क्वेअर रूट घेतलं तर your answer will be different. So please add this particular value first. 1 plus 21.33 into 10 raised to 3 means I think it becomes 22.33 into 10 raised to 3, and then you have to take the square root, and that square root value you have to write as it is. And now the next calculation is very simple. 1 plus 146.061 into 1.25. So what will be this answer, sigma?
183.826 Newton per mm square.
183.82 Newton per mm square. Please check your answers, those who have calculated. 183.82, 183.81, 183.81. Yes, all answers are same now. 183.82 Newton per mm square. This is the stress induced in the bar due to the 500 Newton load strike on the circular disc. काय झाले बघा, हा 500 न्यूटनचा लोड ह्या सर्क्युलर डिस्क वर येऊन आदळल्यामुळे जो काय स्ट्रेस ह्या बार मध्ये किंवा सर्क्युलर डिस्क मध्ये डेव्हलप झालेला आहे, तर दॅट स्ट्रेस व्हॅल्यू इज इक्वल टू 183.82 or 183.81 Newton per mm square. So do the calculation. Understand this particular big calculation. It is very important. The sigma formula is very big, but if you go for more and more simplification, immediately you will get the answer. जेवढं जास्तीत जास्त स्टेप मध्ये तुम्ही सिम्प्लिफिकेशन काढणार आहे तेवढं accuracy of the answer is very good. So try to go for more and more simplification if you are unable to calculate the answer directly. 183.81 Newton per mm square. So this is the stress induced in the rod, or we can consider it as a circular disc. Okay, now the stress is calculated. Now we have to calculate the strain energy. Stress is calculated. Now we have to calculate the strain energy absorbed or the strain energy stored in the bar. So we are having the formula which is common for all the conditions. U is equal to sigma square upon 2E into volume. So sigma square into 2E volume means area into length. So now simply we have to put the value, this capital U, as it is. Sigma just now we have calculated 183.82 square divided by 2 into 200 into 10 raised to 3 into area means 400 into length means 1500. So what is the U value?
50.67 into 10 raised to 3.
10 raised to 3.
50.68
into 10 raised to 3.
50.68 into 10 raised to 7 Newton.
10 raised to 3.
10 raised to 3. Okay. 10 raised to 3. So those who have calculated, send your answers in the chat box. I will check. 50.68 or 50.67 into 10 raised to 3 Newton mm. So this much amount of strain energy stored in the rod. So please do the calculation. This calculation is also very, very important. So here the stepwise marking system is there. So if you will calculate the sigma, you will get the 2 marks. If you calculate the U, you will get the 2 marks. If you calculate the delta L, you will get the 2 marks. So like that, stepwise marking system is there. But if your final answer is wrong, then immediately you will get the 0 marks. So do the calculation 2 times. Verify your answer 2 times. Initially, if you got the 183.82, and if you do the calculation again, you will get the another answer. So try to make the calculation 2 times and verify your answers twice. Yes, 50.68 into 10 raised to 3 Newton mm. Don't forget to write down the unit because separate 1 or half mark is there for your unit writing. 50.68 into 10 raised to 3 Newton mm. This much amount of strain energy absorbed or stored in the bar. Everyone, please send your answers in the chat box. Still few students are sending the answers. Others, they just attending for the attendance purpose only. Sure, all the responses are recorded. 50.67 or 50.68. Both answers are correct. Into 10 raised to 3 Newton mm. And now third, elongation. Elongation of bar. So delta L is equal to sigma L upon E. So this is the formula. Already we have calculated the sigma. So by using that particular sigma only, we have to calculate the deformation. So 183.82 into length 1500 divided by E 200 into 10 raised to 3. Therefore, what is the deformation?
37
1.37.
1.37
mm.
So this is the elongation of the bar. Please check your answer. 1.37 or 1.38, no problem. but it should not be 2.37 or 3.37 or only 0.37. This is the maximum difference. So 1.37 or 1.38, or sometimes you will get the 1.36. That much variation is, it will be accepted in the answers. We checked 1.37. This is the total elongation of the bar. 1.37, 1.37, 1.378. Yes, all the answers are correct. So calculation part is very, very simple, but sometimes we are unable to calculate this much calculation also, because now these big problems are not asked in your MCQ examination, but this little elongation problems, sometimes strain energy problems, all the data is given in the statement. We have to calculate the answer, and from the 4 options, we have to choose the correct answer. So such MCQ questions are also there in your examination. So please keep in mind. I am taking this particular big formulas purposefully. हा एवढा मोठा फॉर्म्युला तुम्हाला एमसीक्यू क्वेश्चन मध्ये विचारला जाणार नाही, पण ह्याच्यामध्ये स्टेप जे काय आपण 3 ह्याच्यामध्ये कॅल्क्युलेशन काढलेला आहे. 1 sigma calculated, second strain energy calculated, and third one elongation calculated. Like this stepwise calculation or stepwise numericals they will ask for the MCQs. They will given all the data in the parameters. We have to solve the problem and we have to choose the correct option from the 4 options. मग त्याच्यामध्ये डेल्टा एल एकदा 1.37 दिलेला असेल, 2.37, 0.37, 1.40, like that variations of answers are given, and from that you have to choose the correct answer. So like that small MCQ questions based on this calculation is also asked in the examination. So for that purpose this formula should be at your tip of tongue, and based on the formulas also, what is the delta L formula, what is the strain energy formula, what is the sigma formula, based on these particular formulas also 101% the MCQ questions will be there. So the formula should be at your tip of tongue. If you are unable to remind the formula, unable to solve the problem, and if you are unable to remind the formula, you are unable to give the correct option from that respective 4 options. That's why I have given one table, and in that particular table all the formulas are there. Okay, so I hope everyone has calculated this particular number, this solution. So this is the one more problem we have solved based on the impact loading condition, where the certain load which is falling from the certain height, and how to identify the problem, whether it is gradually, suddenly, or the impact. If there is an impact load, sometimes they are mentioning the word the load is applied in the impact condition, but if that word is not mentioned, you have to read the statement carefully and you have to check there whether falling height is given or not. If it is not given, either that problem is based on the gradually applied load or the suddenly applied. But the height is given means that problem we have to solve by using the impact loading condition only. And I have given the basic difference between the suddenly applied load and the impact load. For the suddenly applied load, height is equal to 0, and for the impact load, the height is given in the statement. म्हणजे ग्रॅज्युअली सडनली मध्ये पण आपण लोड विदिन फ्रॅक्शन ऑफ सेकंड मध्येच अप्लाय करतोय, आणि इम्पॅक्ट मध्ये पण लोड आपण विदिन फ्रॅक्शन ऑफ सेकंड मध्येच अप्लाय करतोय. फक्त डिफरन्स काय, सडनली अप्लाइड लोड मध्ये हाईट इज इक्वल टू 0 असणार आहे, बिकॉज देर इज अ कॉन्टॅक्ट बिटवीन द लोडिंग फ्रेम अँड द कंपोनंट. अँड सडनली अप्लाइड लोड मध्ये देर इज नो इनिशियल कॉन्टॅक्ट, त्या दोन्हीमध्ये इनिशियल कॉन्टॅक्ट मध्ये नसणार आहे, म्हणजे देर इज अ सर्टन हाईट बिटवीन द लोडिंग फ्रेम अँड द कंपोनंट. So this difference you have to keep in your mind, and it will be helpful for your MCQ examination. Okay, I hope everyone has calculated this particular problem based on the impact loading condition, that is stress calculation, then strain energy calculation, and then elongation calculation. Okay, now one more, another variety of problems we will solve based on this particular type number 3. This is the problem number 3. Something different value we have to calculate. We have to use the same condition, we have to apply the same concept, but some another calculations we have to go for. See, I will read the statement. A weight of 1.2 kilonewton is dropped on the collar attached to the lower end. See, a weight of 1.2 kilonewton is dropped on collar which is attached to the lower end, and length of vertical rod is 4 meter. Length of vertical rod is 4 meter, and there is a 30 mm diameter, full stop. Means here again, when vertical rod is there, the rod is fixed at the top side, bottom side the collar is attached, Okay, length of rod is given 4 meter, their diameter of rod is given 30 mm, and how much amount of load is falling from certain height? Sir, 1.2 kilonewton. Full stop. Calculate height of drop. Calculate height of drop if maximum instantaneous stress is not to exceed 120 megapascal. If maximum instantaneous stress is not to exceed 120 megapascal. Full stop. Also calculate elongation of rod. Also calculate elongation of rod. Take capital E is equal to 200 giganewton per meter square. So what is the difference between this problem and the previous two problem? In the previous two problem, they have given the falling height. What is the height between movable load and the collar? 80 mm, 100 mm, like that height they have mentioned, and we have to calculate the stress value. But here the problem is exactly opposite. Conditions are same. The one rod is there. For example, this figure. See, conditions are same. This is the rod. Rod is fixed at the top side, at the bottom side. This is the collar. Okay. This is the movable load of 1.2 kilonewton. Okay. And this is a certain height. This is the certain height. And this height value now we have to calculate. आतापर्यंतच्या ह्याच्यामध्ये आपल्याला ही certain height दिली होती आणि सिग्माचा फॉर्म्युला वापरून we are directly calculating the sigma value as a stress value. Then we are calculating the strain energy. Then we are calculating the elongation. But if you read this particular statement carefully, conditions are same. But we have to calculate the height of drop if maximum instantaneous stress is not to exceed 120 megapascal. म्हणजे त्या रॉड मध्ये किंवा त्या कॉलर मध्ये किती स्ट्रेस इंड्यूस झालेला आहे, that stress value they have given here, that is 120 megapascal. So what is the meaning of not to exceed? What is the meaning of not to exceed? What it indicates? Instantaneous stress not to exceed 120 megapascal. What is the meaning of not to exceed? Can anybody? Yes? Any answer? I will correct it afterwards. Not to exceed means?
Ultimate stress will be 120 megapascal.
Yes, this is the stress value, no problem. But what is the meaning of not to exceed? Means what it indicates?
Not
this word
greater than 120 megapascal.
Correct. Correct. Whatever the stress induced in this particular rod, it should not be greater than 120 megapascal. Means this 120 megapascal represents the maximum limit of this particular rod. Means this rod or this particular collar can sustain the stress up to 120 megapascal or 120 Newton per mm square. म्हणजे 120 न्यूटन पर एमएम स्क्वेअर पर्यंतच तुमचा हा रॉड किंवा हा कॉलर काय करू शकतो, स्ट्रेस सस्टेन करू शकतो. म्हणजे त्याच्यावर तुम्ही 110 अप्लाय करा, 105 करा, 115 करा, 119 करा, 80, 60, 10, 20, any value which is less than 120 can sustain by this particular rod. But it should not exceed 120 Newton per mm square. Once it will exceed 120 Newton per mm square, there is a possibility of failure. म्हणजे हा रॉड किंवा हा कॉलर फुटर तर काय होणार आहे, ब्रेक होणार आहे. So this 120 Newton per mm square should not exceed the value. Means the maximum instantaneous stress not to exceed 120 megapascal. Means it represents the maximum limit of that particular rod. Getting? So this is the meaning of not to exceed, means this is the maximum limit of the rod. If it will exceed the limit, there is a possibility of failure. So please keep in mind. So 120 megapascal is the maximum stress value of this particular rod, and it is given to you for your further calculation. And what value we have to calculate? We have to calculate the height of the drop. Then which formula we have to use here? So before that, just we will write out all the given parameters. See. Given the P is given 1.2 kilonewton is equal to 1.2 into 10 raised to 3 Newton. Then length is given 4 meter is equal to 4000 mm. Then diameter of rod is given 30 mm. Then sigma is given is equal to sigma max we can consider is equal to 120 megapascal means 120 Newton per mm square. And then E is given 200 giganewton per meter square. हे giganewton meter square म्हणजेच काय असतं तुमचं gigapascal. So 200 into 10 raised to 3 Newton per mm square. And we have to calculate height and we have to calculate the delta. Okay, so this is the problem in front of you. So we have to calculate the height. So for that purpose, if we will use the formula sigma is equal to P upon A in bracket 1 plus 2h upon delta L. In that, we have to calculate the height value. But instead of using that particular formula, if you go for more simplified formula, one formula I have given to you. That is, what is the formula and what is our concept? See. Strain energy is equal to work done. So strain energy formula we are having sigma square upon 2E into volume and work done is equal to P in bracket H plus delta. So this formula is available with you. Strain energy is equal to work done. This value P into H plus delta L means this is the length into height. This is the H into B into L. B into L. B means vertical distance and it is represented by capital B, that is load applied on the rod. And this H plus delta L means that particular load has to travel the distance of H plus delta L. म्हणजे पहिल्यांदा that load will cover the height, म्हणजे हा load वरून पडणार आहे, म्हणजे he has to cover the certain height and due to the application of load there is some deformation. That means total distance traveled by this particular 1.2 kilonewton load is H plus delta L. Means it will travel this particular distance, that is L. And how it is calculated? P into L means this is the rectangular in cross section, and for the rectangular cross section we are having the area formula is equal to B into L or L into B. On the x-axis, length will be considered as a delta L plus height, and on the y-axis, the P will be considered as a capital B, or we can consider it as a small b. So this is the formula where we have to use when we have to calculate this particular height. So if I will write this formula, sigma square upon 2E into area into length is equal to P in bracket H plus delta L means PL upon A. So this is the formula. Now only simply we have to put the values. So sigma is given 120 square divided by 2 into 200 into 10 raised to 3 into area of rod pi by 4 into 30 square into length converted in mm 4000 is equal to P value 1.2 into 10 raised to 3 in bracket H plus delta L means PL upon AE. So P value once again 1.2 into 10 raised to 3 into length 4000 divided by AE. A means pi by 4 into 30 square into 200 into 10 raised to So this is the value we have to keep in the equation. Sigma upon 2e into area into length is equal to capital P value 1.2 into 10 raised to 3 in bracket h plus PL upon E. Now do the calculation the terms which are present at the left side. पूर्ण terms calculation करा and tell me the answer. 120 square divided by 2 into 200 into 10 raised to 3 into pi by 430 square into 400 and tell me the answer. What is the total answer of the term which are present at the left side? Do the calculations properly and send your answers in the chat box. Do the separate calculation of sigma square upon 2e. त्या झाला calculation ला pi by 4 into 30 square ने multiply करा and then again multiply by 4000.
Sir, 101.787 into 10 raised to 3.
3.
Okay, 101. You send your answers in the chat box, so I will verify 101.78 into 10 raised to 3. Okay, okay. This 1.2 into 10 raised to 3 as it is. Okay. Square bracket मध्ये h plus square bracket मध्ये h plus. Yes, 101.787 into 10 raised to 3 correct, or 101.79 into 10 raised to 3. That answer is also accepted, no problem.
Sir, आणि delta L ची value 0.033.
Okay, then do the separate calculation of delta L. जी delta L ची व्हॅल्यू आपण इथे काय पुट केले, delta L is equal to PL upon AE. मग P ची व्हॅल्यू माहित आहे, लेंथ माहित आहे, एरिया माहित आहे, E माहित आहे. इज अ सेपरेट कॅल्क्युलेशन H प्लस जी काय व्हॅल्यू होती, व्हॉट इज दॅट आन्सर?
0.033.
0.033. Okay. First of all, calculate the terms which are present at the left side. Sigma square upon 2e into area into length. Do the separate calculation of the left side term. 101.78 into 10 raised to 3. 101.78 into 10 raised to 3 is equal to P ची value keep as it is, H value as it is, and H plus delta L जो आपण PL upon A ने replace केलेला आहे, तर ती PL upon A ची value calculate separately. Delta L is equal to PL upon A. त्याच्यामध्ये P ची value माहिती आहे, length माहिती आहे, area माहिती आहे, means pi by 4d square into E ची value माहिती आहे 200 into 10 raised to 3. And do the separate calculation of delta L, PL upon A, and put that value in the square bracket. H plus whether it is coming 0.033. Others, please check your answer. 0.033. 0.033, correct. Do the calculation in your calculator and write down this particular answer in your notebook. H plus 0.033. Simply we have to calculate delta L is equal to PL upon AE. P value is given, length is given, area is given in the form of diameter pi by 4d square and into multiply by E. 0.033. 0.033. Okay, now next term 101.78 into 10 raised to 3 is equal to 1.2 into 10 raised to 3 in square bracket H plus 0.033. Our aim is to calculate the height. So we have to take this particular height parameter at one side. एका साइडला कुठे तर आपल्याला height घ्यावी लागेल. So what I will do, let us see. 101.78 into 10 raised to 3 divided by this 1.2 into 10 raised to 3. It is present at the right side and it is multiplied. Okay, 1.2 into 10 raised to 3, it is present at the right side, and here it is multiplied. If I will take this particular term to the left side, here it becomes divide. So 1.2 into 10 raised to 3. इकडच्या बाजूला असताना ती न्यूमरेटरला राईट साइडला असताना ती जर टर्म आपण लेफ्ट साइडला घेतली तर ती कुठे होणार आहे डिनॉमिनेटरला जाणार आहे. सो इज इक्वल टू h प्लस 0.033 as it is. So what is this particular answer?
84.82.
84.819.
81 is equal to h plus 0.033. Then we have to calculate the height. So this height I will keep as it is at the right side. राहिले टर्म कुठले 0.033. 0.033 is present at the right side. त्यामुळे इकडे असताना ती पॉझिटिव्ह आहे. ती जर व्हॅल्यू आपण लेफ्ट साइडला घेतली तर इट बिकम्स निगेटिव्ह, मीन्स 84.81 minus 0.033, and you will get height
84.78.
84.78.
84.78.
correct. 84.78. Please check your answer. 84.78. Those who have calculated. 84.77. Sometimes you will get 84.79. Sometimes you will get 84.78. All the answers are accepted. 84 point something. It is near about 77, 78, and 79. No problem. Why this variation is there? Because digits you are considering for the calculation. So don't worry about that. But it should not be 85 or it should not be 83. Little bit variation it will be accepted. 0.77, 0.78, or 0.79. This much variation is accepted, no problem. But it should not be more than 84 as a 85, 86, or 82, 83 like that. How to calculate the height distance, and for that which formula we have to use? So please keep in mind we are having the concept strain energy is equal to work done. Strain energy formula we are having work done means area under the curve. मग कुठला एरिया असणार ह्या ठिकाणी तर rectangular section. Area under the curve means rectangular section, because there is a common things between the suddenly applied load and the impact load. बघा तुम्ही सडनली अप्लाइड लोडचं जर डेरिव्हेशन तुम्ही आठवचाल तर त्याच्यामध्ये एरिया अंडर द कर्व इज रेक्टँग्युलर सेक्शन आणि ग्रॅज्युअली आपल्याला ट्रायंग्युलर सेक्शन आला होता. फॉर द ग्रॅज्युअली अप्लाइड लोड देयर इज अ ट्रायंग्युलर सेक्शन अँड सडनली अप्लाइड लोड साठी कुठला एरिया आला होता तर रेक्टँग्युलर सेक्शन. व्हाय? बिकॉज सडनली इट इज अप्लाइड विदिन फ्रॅक्शन ऑफ सेकंड. त्यामुळे 0 पासून डायरेक्टली 80 किलो न्यूटन. देयर इज नो एनी 10, 20, 30, 40 लाईक दॅट. सो फ्रॉम 0 डायरेक्ट 80 किलो न्यूटन, आणि त्या 80 किलो न्यूटन साठी डायरेक्ट डिफॉर्मेशन किती येणार आहे? दॅट्स व्हाय देयर इज अ रेक्टँग्युलर सेक्शन. आणि इम्पॅक्ट लोडिंग कंडिशन मध्ये पण वी आर अप्लाइंग द फोर्स सडनली विदिन फ्रॅक्शन ऑफ सेकंड. बट व्हॉट इज द डिफरन्स? दॅट लोड हॅज टू ट्रॅव्हल सर्टन डिस्टन्स, म्हणजे देयर इज अ फॉलिंग हाईट. त्यामुळे त्या हाईटचा इफेक्ट आपण ह्याच्यामध्ये काय केला बघा एच प्लस डेल्टा एल. ह्या ठिकाणी जर हाईट 0 असली असती तर तुमचा एरिया अंडर द कर्व काय असता? पी इंटू डेल्टा एल. Please keep in mind, if height is equal to 0, your area under the curve is P into delta L. But that load has to travel certain distance as a height. त्यामुळे आपण त्याला काय केले? H plus delta L has झाली length and त्याला multiply by B means B into L like this. So that value we have to keep in mind. Okay. And then we have to keep all the values in the equation. Strain energy is equal to work done, and immediately you will get the height. And then second value we have to calculate elongation. Elongation of bar. So delta L is equal to sigma L upon E. So sigma value 120 into length 4000 divided by E 200 into 10 raised to 3. So what is the delta?
2.4.
2.4.
2.4 mm. This is the elongation of the rod or the elongation of the bar, which is fixed at the top side and which is fixed at the, which is free at the bottom side means the collar is attached at the bottom side. So always you have to keep this particular figure in your mind for the impact loading condition. You have to keep this particular figure in your mind. One rod, okay, which is fixed at the top side, bottom side ला एक तर कॉलर अटॅच केलेले असेल किंवा सर्क्युलर डिस्क अटॅच केलेले असेल. ह्या कॉलर पासून सर्टन हाईट वर एक मुव्हेबल लोड असतो. दॅट लोड विल बी कन्सिडर्ड ॲज अ इम्पॅक्ट लोड. आणि ह्या मुव्हेबल लोड मध्ये आणि या कॉलर मध्ये देयर इज अ सर्टन हाईट. दॅट हाईट विल बी द falling height. So try to draw these particular figures also whenever you are solving the problems based on the impact loading condition. In the impact loading, these two varieties are there. First two problems where the load is given, all the parameters are given, and we have to calculate the stress induced in the rod. And for that purpose, height is very very important. So त्याच्यामध्ये जर तुम्हाला height दिली नसेल, we are unable to calculate the stress value. So first of all, we have to calculate the stress value by using the impact load formula. Then we have to calculate the strain energy, and then we have to calculate the elongation. So the first two problems are based on the subtype number 1, and this is the third problem where the stress induced in the rod is given as a given parameter, and we have to calculate the falling height. And then which formula we have to use? We have to use the concept of a strain energy is equal to work done is equal to area under the curve. Area under the curve is the rectangular section. Rectangular section चा area आपल्याला माहित आहे. Area is equal to B into L. B means horizontal distance. Sorry, B means vertical distance. Length means horizontal distance. Horizontal distance means delta L plus H, and vertical distance means force applied on the rod as a capital P. Then we have to keep the values, go for more and more simplification. This calculation is very important. Calculation is very very simple, but we have to go for the more and more simplification. But the left side separate calculation करा, plus the H plus delta L ची value separate करा. Take the unknown parameters at one side and then go for your required calculation. Don't do the direct calculation. Sometimes it will create the problem in your calculation. If it is possible to you, you are able to calculate the direct answers, no problem. But it should be correct. Okay, so this is the problem based on the impact loading condition. Okay, everyone, have you understood the problems based on the type number 3, that is impact loading condition?
Yes, sir.
Anybody is having any problem? You can ask. One common difference and common things I have explained you in between suddenly applied load and impact load. Suddenly applied load मध्ये and impact load मध्ये common difference काय आहे आणि common things काय आहेत, that is very important for your MCQ examination. And once again I am telling, what is the common difference? In suddenly applied load, height is equal to 0. In impact load, certain height is given. And what is the common thing? In suddenly applied load also, we are applying the load immediately within fraction of second, and in the impact load also, we are applying the load within fraction of second. फक्त suddenly applied load मध्ये loading frame मध्ये आणि body मध्ये there is a direct contact, but in impact loading initial contact is not there. म्हणजेच there is a certain distance, there is a certain height between body and the loading frame. So that difference is very important for your MCQ questions. Yes, everyone, have understood the problem based on the type number 3, impact loading conditions? Any problem? Yes, no one is replying. Have you understood the type number 3? Okay. Only one reply I got. What about others? Are they understood or not? Yes, now I got. Yes, I received reply from the B divisions. What about A division students? Have you understood? Okay. Okay, so the problems are very simple. If you read the statement carefully and you understood the type, whether it is gradually, suddenly, or impact, immediately we can use the respective formula and we have to go for the final solution. And only what are the common things of the calculation? Either we have to calculate the sigma, or we have to calculate the strain energy, or we have to calculate the elongation. Only this much three values we have to calculate again and again in each and every conditions. Okay. Now we will discuss about the last type of this particular chapter, that is problems on the strain energy for the varying cross-sectional areas. Up till now, whatever the three types of problems we have solved, it may be gradually applied load, it may be the suddenly applied load, or it may be the impact load. In that, only one cross-sectional area we are considering for the calculation. In the gradually applied load, one horizontal rod is there, and that horizontal rod is subjected to the external load. Again, in the suddenly applied load, again one horizontal rod is there, their diameter is given, and it is subjected to the external load, and we are calculating the further parameters. In impact loading also, one vertical rod is there, their cross-sectional area is given as a diameter, their length is given as a length, and we are calculating the stress induced in the rod, stress induced in that particular bar, or the strain energy stored in the bar, and the elongation of the bar. Means only one cross-sectional area is there, and that single cross-sectional area is subjected to the external load, and accordingly we are calculating the stress, strain energy, and the elongation. But now here, this type number 4 is totally related with the same concept, but the structure is different. And what is the title I have given? So you put your title in your notebook and draw this particular figure also. So what is this particular title indicates? Problems on the strain energy for varying cross-sectional areas. In the chapter number 1, you are having the type number 2, problems on the bars of varying cross section for the delta L calculation. Problems on the bars of varying cross section for the delta L calculation. And how we have calculated that elongation? That is, total deformation is equal to delta L1 plus delta L2 plus delta L3. That means if this particular bar subjected to the external load P, if this particular bar subjected to the external load P, what I am doing? I am calculating the separate deformation of section number 1 as a delta L1. I am calculating the separate deformation for the section 2 as a delta L2, and I am calculating the separate deformation for the section 3 as a delta L3. And same force we are using, capital P as a capital P. P will be common for all the sections. That means capital P is equal to P1 is equal to P2 is equal to P3. Same force we are considering for the section number 1, section number 2, and section number 3. And we are calculating the total deformation as a delta L1 plus delta L2 plus delta L3. Why this bar is called as a bars of varying cross section? Because for the section number 1 having area A1, for section number 2 having area A2, and for section number 3 having area A3. Means section number 1 diameter as a D1, section number 2 diameter D2, and section number 3 diameter D3. And the bars of varying cross section, section number 1 is connected to the section number 2, section number 2 is connected to the section number 3, and by connecting all these particular 3 sections to each other, one bar is formed, and this particular bar is called as a bars of varying cross sectional areas. And in the chapter number 1, we have calculated this deformation. Deformation of total bar is equal to delta L1 plus delta L2 plus delta L3. Similarly, in this particular chapter number 2 also, we have to calculate the total strain energy stored in this particular bar. Total strain energy stored in this particular bar if it is subjected to the single force. जसं सिंगल फोर्स असताना आपण ह्या बारचं टोटल इलॉंगेशन काढलं. कसं काढलं तर टोटल इलॉंगेशन इज इक्वल टू डेल्टा L1 प्लस डेल्टा L2 प्लस डेल्टा L3. Similarly, if same bar is subjected to the one external load P, and due to this particular external load, here this bar is also subjected to the some amount of elongation. This bar is also subjected to the some amount of elongation, but at the same time, due to the single force, some amount of energy is also stored in section number 1, some amount of energy is also stored in section number 2, and some amount of energy is also stored in section number 3. That energies we have to calculate. That is, we have to calculate the U1 as a strain energy stored in the section number 1. We have to calculate the U2 as a strain energy stored in the section number 2. And we have to calculate the U3 as a strain energy stored in the section number 3. And at the end, if I have to calculate the total strain energy, that total strain energy is equal to U1 plus U2 plus U3. And this U1 means sigma 1 square upon 2E into V1 plus sigma square upon 2E into V2 plus sigma 3 square upon 2E into V3. This is the total strain energy formula. जसं आपण delta is equal to delta L1 plus delta L2 plus delta L3. We are calculating, that is delta L is equal to P1 L1 upon A1 E1 plus P2 L2 upon A2 E2 plus P3 L3 upon A3 E3. Same concept we have to apply for this particular chapter number 2, but instead of calculating the deformation, here our focus is to calculate the total strain energy stored in the bar having the varying cross-sectional areas. मग ह्या टोटल बार मध्ये जर आपल्याला स्ट्रेन एनर्जी जर फाइंड आउट करायची असेल तर पहिली रिक्वायरमेंट काय? We have to calculate the separate strain energy in the section number 1, separate strain energy in the section number 2, and separate strain energy in the section number 3. आणि तिन्हीची काढून जर त्या तिन्हीची जर बेरीज केली तर you will get the total strain energy stored in the varying cross sectional area bar. Therefore, the heading is given like that: problems on strain energy for the varying cross sectional areas. Getting? This is the formula we have to use for our further calculation. आतापर्यंत आपण जे काही 3 प्रकारचे प्रॉब्लेम सॉल्व्ह केले त्याच्यामध्ये फक्त एकच सेक्शन असायचा. फॉर एक्झाम्पल लाईक दिस. This is the bar and it is subjected to the external load P. This is only one section. This is only one section. Has a diameter दिलेला असा, has a length दिलेला असा, and we are calculating for the only one section. But now in this particular figure, section 1 ला section 2 connect केलेला आहे, section 2 ला section 3 connect केलेला आहे, and all the 3 sections are subjected to the only one external force. And due to that, some different strain energy stored in the section number 1. ह्या section number मधली strain energy ही वेगळी असणार आहे, section 2 ची वेगळी असणार आहे, section 3 ची पण वेगळी असणार आहे. Why? Because all the 3 sections are having the different cross sectional areas. Means if your cross sectional area is varying, then amount of strain energy stored in that particular section is also get vary. जर तुमचा क्रॉस सेक्शनल एरिया जर चेंज होत असेल तर अकॉर्डिंग टू दॅट चेंज इन क्रॉस सेक्शनल एरिया द अमाउंट ऑफ एनर्जी स्टोर्ड इन दॅट सेक्शन इज ऑल्सो व्हेरिएबल. त्यामुळे स्ट्रेन एनर्जी सेक्शन नंबर 1 मधली, 2 मधली आणि 3 मधली इट इज डिफरंट. व्हाय? A1 is not equal to A2 is not equal to A3. Means the strain energy is varying according to the cross sectional areas, and based on this we have to solve the problems in this particular type number 4. Okay, so you have to draw this particular figure. You have to draw this particular figure in your notebook. Put all the parameters capital P, then at the top side section 1, section 2, section 3. Section 1 चे parameter L1 आणि A1, section 2 चे parameter L2 A2, section 3 parameters L3 A3. And below that you have to write down the formula. Total strain energy capital U is equal to total strain energy capital U is equal to U1 plus U2 plus U3. Total strain energy capital U is equal to U1 plus U2 plus U3, and त्याच्याच खाली capital U is equal to U1 means sigma 1 square upon 2E into volume as a volume V1 plus U2 is equal to sigma 2 square upon 2E into volume V2 plus U3 means sigma 3 square upon 2E into volume V3. So write down this particular formula in your notebook. Based on this, we have to solve the numerical. I think my screen is visible to you.
No, sir.
My screen is visible to you.
No, sir.
Yes, screen is visible.
Yes,
No,
sir.
sir.
I think there is some problem. Just wait. Meanwhile, you just draw the figure, write on the formula. Capital U is equal to U1 plus U2 plus U3. Write on the separate formula for the U1. It represents the strain energy for the section 1. U2 means strain energy for section 2 and U3 means strain energy for section 3. And strain energy formula for all the section is same. Sigma square upon 2E into volume. For U1 represent the sigma in the form of sigma 1 and volume in the form of V1. Similarly for the U2 sigma 2 V2 and U3 sigma 3 and V3. Like that we have to write. So due to the light problem, I'm unable to share the screen from the computer. So we will wait for the few minutes. Meanwhile, you draw the figure, write down the formula.
Okay, let us wait for 1 or 2 minutes. We'll connect from another device. Wait for the few minutes. I'm joining from another device. Okay, is my screen is visible? Yes.
Yes, sir.
Okay. 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 So we are discussing about the strain energy stored in the bars of varying cross-sectional areas, and just now we have discussed about the how to calculate the strain energy in the bars of varying cross-section. So for that purpose, what is our requirement? We have to calculate the separate strain energy for the section number 1, separate strain energy for the section number 2, and separate strain energy for the section number 3. Okay, and the total strain energy is equal to capital U is equal to U1 plus U2 plus U3. Or if you give the name to this section, this is the A, B, C, and D. Okay, that means section number 1 means section AB, section 2 means section BC, and section 3 means section CD. That means the total strain energy is equal to U of AB plus U of BC and plus U of CD. Or we can consider it as a U1 plus U2 plus U3. That means how to calculate the total deformation? Total deformation is equal to delta L1 plus delta L2 plus delta L3. Similarly, to calculate the total strain energy is equal to U1 plus U2 plus U3. And then what is the formula for the U? Same formula. U is equal to sigma square upon 2E into volume. Don't send the attendance. I have not asked you to send the attendance in the chat box. I will take the attendance separately. Don't worry about that. So the strain energy formula same. U is equal to sigma square upon 2E into volume. If we are calculating for the section number 1, then you have to take the sigma 1. you have to take the volume 1. If you have to calculate the sigma 2 or U2, then you have to take the sigma 2 for the calculation and V3 for the V2 for the second calculation. And if you have to calculate the U3, then you have to calculate the sigma 3 and the V3. That means the total strain energy U is equal to U1 plus U2 plus U3. And that U formula will be same for all the 3 sections. That is sigma square upon 2E into volume. Okay, so this is the basic introduction related to the type number 4, that is problems on the strain energy for the varying cross-sectional area and their formula. Have you taken this particular figure and the formula in your notebook? Have you taken the formula?
Yes, sir.
Total strain energy capital U is equal to U1 plus U2 plus U3. Okay, and now we will solve one problem based on this particular bars of varying cross section. Okay, so this is the statement in front of you. So you just read the statement carefully, and if you read the statement carefully, you will understood what exactly they have given and how to calculate the total strain energy in the bar. Okay, so read the statement carefully. The maximum stress produced if pull in the bar of length 1 meter is 150 Newton per mm square. So what they have given, the maximum stress produced in the bar. The maximum stress produced in the bar of 1 meter length. So what is the total length of the bar? Here they have mentioned 1 meter. This 1 meter represents the total length of the bar, and in that 1 meter length of the bar, the maximum stress produced is 150 Newton per mm square. Okay, full stop. The area of the cross section and length shown in the figure. So the length of each section and their cross sectional areas they have represented in the figure which is given below. Full stop. Calculate the strain energy in the bar. That means here we have to calculate the total strain energy stored in the bar and take capital E is equal to 2 into 10 raised to 5 Newton per mm square. Now, if you see the figure, so here one figure is there like this. I will draw the figure once again. This is the figure. This is the figure in front of you. Okay, so this is A. This is the AB section. Then this is BC and this is CD. That means this is the section number 1. This is the section number 2, and this is the section number 3. Okay, for the section number 1, the total length is given. For section number 1, total length is 475 mm. For section 2, length is given 50 mm, and for section 3, again length is given 475 mm. Okay, for each and every section, separate length is given. Then the section number 1 is having the cross sectional area 200 mm square. Section number 2, cross sectional area 100 mm square, and section number 3, once again the cross sectional area 200 mm square. That means section number 1 and section number 3 are similar to each other, because for section number 1 length is 475 mm, for section number 3 length is 475 mm. For section number 1 area 200 mm square, for section number 3 area 200 mm square. But for section number 2, the length is 50 mm and area is 100 mm square. So what will be the total length? 475 plus 475 plus 50 mm. What is the total length of the bar? 475 plus 475 plus 50. What is the total length?
1000.
1000. And they have mentioned in the statement the maximum stress produced in the bar of length 1 meter. 1 meter means if I will convert it in mm, so it becomes 1000. And very important dimensions they have represented in the figure, that is cross-sectional area and the length of each section. Okay, so this is the given parameters, and what they have asked, we have to calculate the total strain energy in the bar. means what is our requirement? We have to calculate the total strain energy stored in the bar. Means we have to calculate the strain energy in the section number 1, strain energy in the section number 2, and the strain energy in the section number 3. ह्या तिन्ही सेक्शन मध्ये strain energy वेगवेगळी find out करायची, and we have to make the addition, and then you will get the total strain energy stored in the bar. Now, in addition to that, they have given the maximum stress is equal to 150 Newton per mm square. They have given the maximum stress is equal to 150 Newton per mm square. So below that, before that, if I will write all the given, here I will write maximum stress is equal to 150 Newton per mm square. Okay, then total length 1 meter is equal to 1000 mm. Okay, then area of section number 1, I will write, see, A1 is equal to A3 is equal to 200 mm square. It is same, it is mentioned in the, then L1 is equal to L3 is equal to 475 mm. Then for section 2, A2 is equal to 100 mm square, and L2 is equal to 50 mm. And what we have to calculate? We have to calculate the total strain energy, means total bar काय आपला from A point to the D point, that is U of AD is equal to, or we can consider capital U is equal to. Both are same. U of AD लिहिलं काय किंवा capital U लिहिलं काय, both are same. That is, we have to calculate the total strain energy. Then what will be our formula? Capital U is equal to, for U of AD is equal to, first U of AB plus U of BC plus U of CD is equal to sigma square upon 2E into volume plus sigma AB square, then sigma BC square upon 2E into volume plus sigma CD square upon 2E into volume. So this will be our formula. But volume we can calculate. Volume is equal to area into length. प्रत्येक सेक्शनचा आपल्याला एरिया दिलेला आहे, प्रत्येक सेक्शनची लेंथ दिलेली आहे, त्यामुळे V1, V2, V3 we can easily calculate. But to calculate the sigma, they have not represented the force value in the figure or in the statement. त्या स्टेटमेंट मध्ये आपल्याला ह्या टोटल बार वर किती फोर्स अप्लाय झालेला आहे, that value they have not given, but they have given one maximum stress value, and it is equal to 150 Newton per mm square. So maximum stress value 150 Newton per mm square. Here we can apply one concept, that is, what is that? Stress is maximum where area is minimum. Now please tell me, in the given figure, which area is minimum, whether section 1, section 2 or section 3?
Section 2.
Section 2 is minimum, because if you see the area A1 for the section number 1, 200 mm square. For section number 3, again it is equal to 200 mm square. But if you see the area of the cross-sectional area 2, it is 100 mm square. That means second section is having the minimum area. Now please tell me, this 150 Newton per mm square maximum stress value is given, whether it is applicable for section number 1, section number 2 or section number 3, as per the statement.
Section 2.
Section 2. What about others? I want answer from each student. 150 Newton per mm square stress is applicable for section 1, 2 or 3?
2.
It is applicable for the section number 2. कारण जिथं स्ट्रेस मॅक्सिमम असतो त्या ठिकाणी एरिया मिनिमम असतो, आणि ज्या ठिकाणी स्ट्रेस हा मिनिमम असतो त्या ठिकाणी तुमचा एरिया काय असतो, मॅक्सिमम असतो. वी हॅव स्टडीड इन द चॅप्टर नंबर 1. स्ट्रेस इज मॅक्सिमम where area is minimum and stress is minimum where area is maximum. Therefore I have written the statement, stress is maximum, where area is minimum. Therefore, from figure section 2, from figure section 2 have minimum area. So I can consider sigma of BC is equal to 150 Newton per mm square. म्हणजे sigma of BC you will get because section 2 will be considered as a BC section. Then how to calculate sigma of AB and sigma of CD, because it is also required to calculate sigma of AB and sigma of CD. जर आपल्याला it is also required to calculate U of AB and U of CD. The strain energy for the section 1 and section number 3, if we have to calculate, before that we have to calculate their stress value. But here they have given only single stress value, that is stress in the section BC. But we are having another concept. See, we have sigma is equal to P upon A. We have sigma is equal to P upon A, means P is equal to sigma into A. Means this total bar, it is subjected to the external load P. This total bar, it is subjected to the external load P, and this P value we are considering same for section number 1, for section number 2 and for section number 3. जेवढा काय एक्सटर्नल फोर्स हा बाहेरच्या बाजूला आपल्याला झालेला आहे, तो एकच फोर्स आपण सेक्शन 1 ला पण कन्सिडर करतो, सेक्शन 2 ला पण कन्सिडर करतो आणि सेक्शन 3 ला पण कन्सिडर करतो. त्यामुळे मी मगाशी सांगितलं होतं कॅपिटल P इज इक्वल टू P1 इज इक्वल टू P2 इज इक्वल टू P3. ज्यावेळेस आपण डेल्टा एल फाइंड आउट करतो, डेल्टा एल इज इक्वल टू डेल्टा L1 प्लस डेल्टा L2 प्लस डेल्टा L3, आणि त्या डेल्टा एल मध्ये P1 L1 अपॉन P1 L1 अपॉन A1 E1, P2 L2 upon A2 A2 and P3 L3 upon A3 L3. But in that, the capital P is equal to P1 is equal to P2 is equal to P3. That means same force value which is applied externally, we are considering for all the 3 sections. And same concept we have to consider for this numerical also, that is total stress value is equal to force upon area. Means capital P is equal to sigma into A, means I can say that sigma of AB into area of AB is equal to sigma of BC into area of BC is equal to sigma of CD into area of CD. What I have done? I have done sigma is equal to P upon A. The same formula I have written in the form of P is equal to sigma into A, means the common force is applied on all the 3 sections. That is capital P is equal to P1 is equal to P2 is equal to P3. And this formula I have made applicable for all the 3 sections. The capital P is equal to P1 is equal to P2 is equal to P3 जर असेल तर left hand side जर equal देत असेल तर right hand sides are also becomes equal. Means sigma of AB into area of AB is equal to sigma of BC into area of BC is equal to sigma of CD into area of CD. पण ह्याच्यामध्ये sigma of AB is equal to sigma of CD असणार आहे, कारण दोन्हीचं क्रॉस सेक्शनल एरिया सेम आहे. एरिया ऑफ AB is equal to area of CD, त्यामुळे ह्या दोन्ही टर्मच्या ऐवजी फक्त मी एकच टर्म घेतो, sigma of AB into area of AB is equal to sigma of BC into area of BC. Okay, therefore sigma of AB as it is into area of AB दिलेला आहे आपल्याला किती 200 is equal to sigma of BC means maximum stress value 150 into area of delay, area of BC delay 100. Now calculate sigma of AB is equal to 150 into 100 divided by 200. Therefore sigma of AB value, what is the value? Calculate the answer.
75.
75.
75 Newton per mm square, which is equal to sigma of AB जर एवढी व्हॅल्यू असेल तर what is the value of sigma of CD?
75.
75. Therefore, sigma of AB is equal to 75 Newton per mm square is equal to sigma of CD. Please keep in mind why it is equal, because if you see the figure, in the figure, section 1 and section 3 cross-sectional areas are same, that is 200 mm square, 200 mm square. Lengths are also equal, 475, 75, 475. त्यामुळे जेवढा स्ट्रेस सेक्शन 1 मध्ये इंड्यूस झालेला आहे तेवढाच स्ट्रेस सेक्शन नंबर 3 मध्ये पण इंड्यूस होणार आहे. So please keep in mind. And how it is calculated? For the further calculation, maximum stress value is given, and तो maximum stress value कुठं असणार आहे, जिथं एरिया मिनिमम असणार आहे. आणि फिगर मध्ये सेक्शन 2 चा एरिया मिनिमम आहे. मग त्या स्ट्रेसचा वापर करून दुसरे स्ट्रेस कसे काढले, तर वी आर हॅव्हिंग द फॉर्म्युला सिग्मा इज इक्वल टू पी अपॉन ए. तर पी इज इक्वल टू सिग्मा इंटू ए मीन्स total force applied on bar is equal to total force applied on the bar is equal to P1 is equal to P2 is equal to P3. मग लेफ्ट हँड साइड जर तुमच्या इक्वल येत असतील तर तुमच्या राईट हँड साइड पण इक्वल येणार, म्हणजेच सिग्मा ऑफ AB इज इक्वल टू एरिया ऑफ AB, सिग्मा ऑफ BC इज इक्वल टू एरिया ऑफ BC and सिग्मा ऑफ CD इज इक्वल टू एरिया ऑफ CD. ह्या दोन्ही कॉम्बिनेशन फक्त मी सिग्मा ऑफ AB घेतला, त्याच्यावरून आपण सिग्मा ऑफ AB व्हॅल्यू वी हॅव कॅल्क्युलेटेड. Okay, now all the stress values are having, so we are having sigma of AB is equal to sigma of CD is equal to 75 Newton per mm square. Then calculate U of AB is equal to U of CD is equal to sigma AB square upon 2E into volume. Okay, then put the value. U of AB is equal to sigma of AB, or here area of volume of AB. So sigma of AB we have calculated 75 square divided by 2 into 2 into 10 raised to 5 into volume of AB means area of AB into length of AB. So now put all the values. U of AB is equal to 75 square as it is divided by 2 into area of AB already given 200 into length of AB already given 475. Therefore, U of AB is equal to, tell me the answer. Strain energy
1.33 into 10 raised to 3.
1.33
into 10 raised to 3.
into 10 raised to 3 Newton mm. Everyone please do your calculation in your notebook and send me the answer in the chat box for the verification. U of AB is equal to 1.33 into 10 raised to 3. Let me check. Yes, 1.33 into 10 raised to 3. 1.33 into 10 raised to 3 Newton mm. 1.33 into 10 raised to 3 Newton mm. If U of AB is equal to this, but U of AB is equal to U of CD. Therefore, U of CD value also remains same, that is 1.33 into 10 raised to 3 Newton mm. Because in the total strain energy calculation we have to consider the effect of third section also. कारण ह्या फिगर मध्ये 3 सेक्शन एकमेकाला कनेक्ट केलेले आहेत, त्यामुळे जरी तुम्ही U of AB काढलेला असेल तर ती आलेली U of AB व्हॅल्यू we have to consider for the U of CD also. And U of AB is equal to U of CD. Why? Because their cross sectional areas are same. जर त्याचे क्रॉस सेक्शनल एरिया जर सेम असतील तर त्याच्यामध्ये स्टोर होणारी स्ट्रेन एनर्जी पण काय असणार आहे, सेम असणार आहे. Therefore, it is equal to 1.33 into 10 raised to 3. Now next, then U of BC is equal to sigma BC square upon 2E into volume of BC. So is equal to sigma BC square upon 2E into volume means area of BC into length of BC is equal to sigma of BC already given, that is 150 square divided by 2 into 10 raised to 5 into area 100 mm square into length 50. So you will get
281.25 Newton.
281.25. Let me check. Correct. 281.25. Those who have calculated, send your answers. 281.25 Newton mm. 281.25 Newton mm. So this is the strain energy stored in the second section, and it is different than the section 1 and section 3. Why? Because cross-sectional areas are different. So please keep in mind, the amount of strain energy stored in the bar is varying according to the cross-sectional areas. And for the second section, it is 281.25 Newton mm. Then calculate the total strain energy. If you have calculated this value, then it is very simple. Simply you have to do the addition. Then total strain energy in bar, in bracket I will write U of AD is equal to U of AB plus U of BC plus U of CD. So 1.33 into 10 raised to 3 bracket complete plus second bracket 281.25 plus third bracket same value 1.33 into 10 raised to 3 Newton mm. So total strain energy stored in the total bar, that is AD, is equal to
2.94
2.94 into 10 raised to 3.
2.94 into 10 raised to 3 Newton mm. This is the total strain energy stored in the bar. This calculation is same like a deformation calculation. How we have calculated the total deformation? We have calculated delta L1 separately, delta L2 separately, delta L3 separately. And then we have made addition of all and we have calculated the total deformation. Same concept we have applied here also. The same bars of bearing cross section is there. In that, maximum stress value is given. By using that maximum stress value, we have calculated the minimum stress value. Because stress is maximum where area is minimum. Area minimum, that value we have considered as the maximum stress value. And by applying the concept, total force applied on the bar is equal to P1 is equal to P2 is equal to P3. जरी तो बार बाहेरच्या बाजूला अप्लाय झालेला असेल, जरी तो फोर्स बाहेरच्या बाजूला अप्लाय झालेला असेल, तर सेम फोर्स व्हॅल्यू we have to consider for section 1, section 2, section 3 means capital P is equal to P1 is equal to P2 is equal to P3. मग लेफ्ट हँड साइड जर इक्वल येत असतील तर sigma AB, area AB is equal to sigma BC into area BC is equal to sigma CD into area CD. Then by taking the two combinations, we have calculated sigma AB. बघा मग sigma AB ची व्हॅल्यू किती आलेली आहे 75 न्यूटन पर mm square. आणि ती जर आपण 150 बरोबर जर कंपेअर केली तर it is very less. Why? Because in the figure the stress is minimum where area is maximum. म्हणजे एक कंडिशन आपली सॅटिस्फाय होते. कुठली? स्ट्रेस इज मॅक्सिमम वेअर एरिया इज मिनिमम. मिनिमम एरिया कुठे आहे तर सेकंड सेक्शनला. आणि सेक्शन 1 आणि 3 चा स्ट्रेस किती आलेला आहे 75 न्यूटन पर mm square. It is very less as compared to the 150. Why? Because stress is minimum where area is maximum. मग एरिया मॅक्सिमम कुठे आहे तर सेक्शन 1 साठी आणि सेक्शन 3 साठी किती आहे 200. It is maximum than 100 mm square. Means our second condition is also satisfied. मग तिन्ही जर स्ट्रेस व्हॅल्यू तुम्हाला मिळाल्या असतील तर तीन सेक्शन मधल्या स्ट्रेन एनर्जी फाइंड आउट करा बाय युजिंग द सिंगल फॉर्म्युला. विच फॉर्म्युला? सिग्मा स्क्वेअर अपॉन 2E into volume. Then we have taken their respective stress values. We have taken the respective volumes, area into length. The two strain energy values are constant. That is U of AB is equal to U of CD. For the second section separately we have calculated and we have got the answer. The total strain energy is equal to 2.94 into 10 raised to 3 Newton mm. So this is the one sample problem, how to calculate the total strain energy stored in the bar having varying cross-sectional areas. Getting everyone have understood this particular problem, how to calculate it?
Yes, sir.
Okay, so this is the one sample problem we have calculated. This value represents the total strain energy stored in the bar, that is 2.94 into 10 raised to 3 Newton per mm. So actually this is not part of your syllabus, but this additional things I have explained you because sometimes up till now in the type number 1, 2, 3, we have discussed about the single statement, and in that only single figure is there, single component is there, which is subjected to the only one cross-sectional area, only one length, and only single force. But if the number of cross-sectional areas are connected to each other, and in that, if we have to calculate the strain energy, then how to calculate? Same concept we have to apply. Only difference is that we have to calculate the separate strain energy for all the sections, and at the end, we have to make the additions. Okay, so this is the one sample problem. Just I want to explain you how to calculate the strain energy in such conditions. Then this is the problem. Okay, everyone have you understood this particular statement? Have you understood the solution, how it is to be calculated?
Yes,
Anybody is
sir.
having any problem? Okay, so with this particular problem, last problem, we have finished our chapter number 2, that is strain energy and the impact load. So what we have discussed in this particular chapter, so we are starting with very basic point, that is what is meant by the strain energy. For that purpose, I have given the example of that string, arrow, then example of spring, then second example of that particular hammer. So how the strain energy stored in that particular body, that I have explained in the first lecture. Then also I have explained how strain energy is equal to work done is equal to area under the curve, because when body is subjected to the external load, their deformation is taking place. Means load has done some amount of work. जर आपण लोडच अप्लाय केला नाही तर डिफॉर्मेशन होणार नाही, म्हणजे तो लोड त्या बॉडीवर कुठल्याच प्रकारचं वर्क कॅरी आउट करणार नाही. But when deformation is taking place, means that load has done some amount of work, means strain energy is equal to work done. मग work done कसं काढायचं? तर area under the curve. Means you will get the area as a triangular section and area as a rectangular section. And we have discussed the basic definition of the strain energy, which is called as the resilience. Then we have discussed about the proof resilience, and then we have discussed about the modulus of resilience. Three definitions are very, very important. Then we have derived the formula for the strain energy. U is equal to sigma square upon 2E into volume. That derivation also we have derived. Then we have derived the remaining two derivations. The formula sigma is equal to P upon A for the gradually applied load. The formula sigma is equal to 2P upon A for the suddenly applied load. These two derivations are also very, very important. And then I have given the direct formula of the impact loading condition. Sigma is equal to P upon A in square bracket 1 plus square root of 1 plus 2H upon delta L. And based on the type number 1, type number 2, and type number 3, we have solved the numericals. Very simple and the straightforward numericals are there. We have to read the statement carefully and we have to check whether it is in condition number 1, condition number 2, or condition number 3. And accordingly, we have to take the sigma formula. Sigma is equal to P upon A, sigma is equal to 2P upon A, and sigma is equal to impact load formula. Strain energy formula will be same for all the three conditions. And delta L also same. Delta L is equal to sigma L upon. Okay. Then we have solved the problems based on the kinetic energy also. काही वेळेला प्रॉब्लेम मध्ये सडनली अप्लाइड लोड इम्पॅक्ट लोड अशी कंडिशन दिलेली नसती, मग तो प्रॉब्लेम सॉल्व्ह कसा करायचा? सो फॉर दॅट पर्पज दे हॅव मेन्शन द स्पीड ऑर व्हेलॉसिटी इन द स्टेटमेंट, आणि त्याच्यापासून आपल्याला कायनेटिक एनर्जी फाइंड आउट करायची, अँड दॅट कायनेटिक एनर्जी इज इक्वल टू स्ट्रेन एनर्जी. Kinetic energy is equal to strain energy. So that concept you have to keep in mind, and we have to calculate the further solutions. And this is the last type, type number 4 we have discussed, where we have calculated the total strain energy stored in the bar. How it is to be calculated? Total strain energy is equal to strain energy stored in the section number 1 plus strain energy stored in the section number 2 plus strain energy stored in the section number 3, and सगळ्याची बेरीज करून you will get the total strain energy stored in the total bar. So this is about the all the things related to the chapter number 2. Everyone have understood the chapter number 2, all the concepts, all the numericals, concepts? Someone mic is on. Tejal. Someone mic is on. Tejal Kasbe.
Yes, sir.
Your mic is on. Okay, is everyone has understood the chapter number 2? Anybody is having any problem? Yes. Everyone has understood? I'm asking to all the students. Everyone has understood this particular chapter number 2, all the types of problems, all the important
Yes, sir.
definitions, all the important concepts. If anybody is having any problem, you can ask. Okay. So with this particular problem, we have finished this particular chapter number 2. In the next lecture, whenever our next lecture will be there, you are having MCQ test 2 on the chapter number 2. So please be prepared for the next MCQ test 2. Whenever our next lecture will be there, maybe on the Wednesday, or maybe tomorrow, if I will get any extra lecture, in that also I will conduct that particular test. So whatever the things I have told during the explanation, you have to be ready for that. I will send the scanner notes also on the WhatsApp group. I will send the MCQ booklet once again on the WhatsApp group. So you have to be prepared and be ready for the second MCQ test on the chapter number 2. Okay. And with this, I hope everyone has understood. Still, if anybody is having any problem, anytime you can ask me, or now also there is a time. I will give the 1 minute. If you have any problem, you can ask me. I will explain the things once again. Okay, with this, we will stop.